briefly I will discuss because I have to hand over the discussion to Terry. Already we have discussed a lot regarding the alternate energy source, biomass, hydrogen, these two are the proven technology, and biomass we have discussed in last PPT. Okay. And another thing like some participants asked what are the in feedback also you have given some data regarding India. This is required. What are the initiatives of government of India? They will discuss in details because they are preparing the all the roadmaps of decarbonization in India. Therefore, Terry will discuss it in details. But by 2070, India government started net zero. Okay, and I have discussed. We have taken the decision how stepwise manner we will go for net zero by 2070. One, if you see up to 2030, India will increase its non-fossil fuel energy capacity. This is as per the COP25 commitment. The Prime Minister of India announced the Pancham Bridge. You know about the Pancham Bridge. And now one stage is like by 2030, India will increase non-fossil energy capacity to 500 gigawatt. Okay, by meeting up to 50% of its energy requirement from renewable sources. Okay, and India will reduce carbon emission by 1 billion tons. I don't know how much it will achieve, but it was target. It was the target in COP26 summit. Okay. Another is like it means 2030 you can see 2030. It means gradually we are going to invest or we take initiative for renewable energy. I will show you the India's initiative. Not only the final project, but projected investment. Okay, total projected investment towards the renewable energy sources. Okay, or towards the decarbonization. And by 2050, when hydrogen will be commercially available in India, it will directly go for steel making. Beginning for green hydrogen in India is where no sintering will happen. It means they are telling you after 2050, what should be our target like sintering we have to obsolete. It means still now we are not telling about the scrapping out the blast furnace, but scrapping out the sinter. It means you have to focus on more DRI. Fixed pallets. By 2070, India will prefer to begin with green DRI. Okay, we will directly go for steel making. But I think 2070 time will say what will happen.
हम लोग नहीं रहेंगे
Therefore, we can propose it by 2070.
मैं रहूँगा
So, what should be the steps? One is the existing blast furnace will stay because our main strength is blast furnace. Although we are the largest producer of DRI, but blast furnace group we cannot obsolete. But we can use 50% renewable energy. Development of therefore second thing what we have to take is our presentation. Development of capturing CO2 will be the major one. Because we want to reduce the CO2 emission and we want to keep the blast furnace. Okay. Then we have to manage CC or CC waste. I will show you. Therefore, the agreement with the collaboration with European Union. I will show you. We are investing in blast furnace. Although the replacement potential is 10%. Okay. But we have to increase it. Blast furnace injection, fuel injection. Implementation of natural gas in each oil, which JSW is doing. Okay. Then the government initiatives. You can see, as I already discussed, is CO2 capture and utilization should be the prime concern in first stage, like our 2030, should be the prime concern. Therefore, government of India, you can see, they have taken the initiatives to research in this government like fast shield. It is collaboration with UK. Collaboration is in carbon capture, utilization and storage in India and the UK.
सर प्रीवियस स्लाइड में पॉइंट नंबर 3 बोल रहा है कि अमोनिया उसको कैप्चर करेगा CO2 गैस को।
अमोनियम कार्बोनेट बनता है।
Development of capturing CO2 will be implemented by using ammonia, when CO2 will release the ammonia will capture the CO2 gas and
डैम इनसाइड प्लांट मतलब
a lot of technologies are developing, like one is storage, one is utilization. Utilization is another thing. But in case of storage, you have to stabilize. Means CO2 you have to stabilize. It may be alkaline media there, ammonia is there. You have to fix the CO2 so that it forms a stable compound and you can dump it.
अमोनियम कार्बोनेट।
A lot of research are going on, only not only for the ammonium carbonate. Okay. So, but the problem is the geologists, they are what is that? The problem is like the stability or life of this compound. How long it will stay as a compound? Is there any effect or long-term effect or dissociation of that compound so that in future CO2 will again revert back? These are the issues. Okay. So then you see the past initiatives like joint collaboration with UK, Government of India. Another, if you see the initiative for research development, Ministry of Environment and Forest and Climate Change India has raised their hand to achieve a 280 gigawatt of installed solar power by 2030. You can see press release. Yeah. And additional allocation of rupees 19,500 crore will be made for production initiative scheme. Okay. For manufacturing of high efficiency solar modules. It means if we have to make the hydrogen with renewable energy solar area, we have to concentrate. India is for tropical country. Therefore, if you see the average sunshine day is high in case of India. Therefore, we have two benefits. One is growing of biomass. It is very high, potential is high. Another one is the solar energy. It is going to be high. If you compare the north and south, we are in a strategic location. Okay. India this type of benefit. Another, if you see, it is called mission innovation. Okay. mission innovation, a global initiative of 23 countries and the European Union to accelerate the global clean energy innovation. Okay. The FO is undertaking research and development with member of MI countries to identify and prioritize breakthrough challenges in the field of CO2 capture. You can see Indian government initiative they have started regarding the CO2 capture first. After that, the generation of production of the renewable energy sources. This is another initiative. It is called the Urja Vikas Nigam Limited. Madhya Pradesh Urja Vikas Limited is actually established in a global leader in solar energy, especially focusing on the solar energy investment. If you see the different initiatives taken by giant reputed steel industry, one is the ArcelorMittal. Two main purposes to reduce the carbon footprint. One is the innovative BRI, so called smart carbon innovative BRI is focused on using the hydrogen in the direct reduced iron process, means hydrogen based BRI production. Another steps is like in GSPL during financial 2022, GSL reduces carbon emission by 3,100 metric tons and initiated a switch from thermal energy intensive manufacturing setup to the renewable energy alternatives. Okay, these are the different reports, complex reports I have prepared. Another one is the JSW Steel that is sitting here. Especially use green power from the 3,800 ton hydrogen plant being set up at its Vijayanagar plant. What is the status, sir?
Which one? 4 million ton.
First one.
And do you plan setup?
This has been postponed, and we have started a 24 megawatt electrolyzer that will go to DRI.
But your target was
2025, but this has been shelved.
24 megawatt, how much production will be there?
10,000 cubic meter.
this is the initiative of GSPL
In a year, metric ton?
DRI electric arc furnace route has been adopted for manufacturing industry. Okay, to overcome the challenges of non-availability of intermittent syngas, they will generate. And it will be the first kind of plant in India and only the second in the world by this type of DRI production in India.
Single is that coal gasification कर दी.
Then you think about the 2050. When the hydrogen will be commercially available, then it will be directly used for steel making. Then obviously the investment should be regarding the hydrogen production. Okay. Projected, I will discuss regarding the projected investment. Because still now we cannot say how much it is invested. Okay. So projected investment, like one is the Reliance industry. Okay, achieving net zero carbon 2035 and are investing over 10 billion tons, near about 75,000 crude. Okay, it is available. Then number 2 is the GAIL, gas operator of energy. Okay, they have also received GAIL awards contracts to set up one India's largest frame-based green hydrogen. Okay.
So has this been commissioned in November 2023?
Press release, any press release of 2020.
No, but
What is the current situation?
GAIL has laid down.
Therefore, I have
They have laid down the pipelines.
laid down the pipelines.
बना देंगे
अब चार्ज हुआ कि नहीं पता. They have laid
Similar
down.
initiative by NTPC. Okay. Indian Oil, L19. Okay. HPCL, BPCL, Adani Group. You know the story of hydrogen injection.
no.
Stories
Sir,
no sir means they have tried.
It's a sample.
They just
Sir, it was for I think 1 or 2 years for 30 minutes,
Then short.
and that was a press release.
That was the strategy.
Yes. Then over.
Number 2 is the Heisenberg process. Having implementation of the Heisenberg process.
There's an easily.
I asked Devashish Chakraborty, is the name of the CEO of Partnership. I think Devashish Chakraborty last meeting, NKT. Sir, what is the status of Heisenberg? Because Heisenberg is actually Tata Steel technology. The Heisenberg is coal-based. The beauty is, like, if you use the coal fines directly, along with this iron fines, it will produce the metal. Okay? It is one type of very high speed smelting process. So you can see here, iron or coal, it will be injected there, and it will form the hot metal and slag. What are the beauty is, it is not required any verification. It is not required any accumulation. It is not required any means coke making. Okay. So you can cut down all the intermediate step of the steel making. Therefore, I discussed the smelting reduction. Smelting reduction is similar. This is also smelting reduction. But there the beauty is, if you go for, the problem is like the coal, use of coal, it is procedural. This is only the problem. Otherwise, if you see all other advantageous position. So you can see earlier you can get some data from Heisenberg development, but now it is stopped. It means the plant is stopped. No. As I asked Devashish sir in our IIM meeting, IIM executive committee meeting, I was Holiday Council member. So he told me that something is going on. When it will be stabilized, it will be under it will be continuous. It means they are developing this process. Tata Steel Netherlands actually developing this process again, revamping this process. Because earlier the problem was the refractory issues, number 1. Number 2, the nozzle problem. They are revamping these issues. I think within some next 5-10 years, they will give a newer technology, slightly replacing the conventional Heisenberg process. And it will give, there is protection to reduce the CO2 emission to a greater extent in this process. But commercial is difficult. They have the pilot type of plant in the Netherlands. Then directly I have to go back.
So the issue with
This is the projected investment. You are telling me how much this project is.
the issue with FBR, Hi4, Hyrex, Isarna is that it is easy to reduce and smelt, but there is an enormous amount of jamming of materials they are unable to handle. There is a call should be taken for development of high temperature refractory ceramic materials, which is not happening.
But as far as his commitment, the views, he told me something is going on. It means they are trying to develop, revamp it. This is the projected, like Niti Aayog, Government of India, any Government of India, DSTP, etc. NTPC, IOCL, L19, Renew, ONGC, HPCL, BPCL, Adani, Tata Steel, Vedanta. These are the it's projected or committed investment. have done 4 types of concrete. One is related to impurities removal, means the steel making, directly steel making, one step steel making process. Hide the patent, it is already published. Number 2 is direct stainless steel production. Number 3 is from the waste, smelting of the waste to recover the alloys. And fourth one we have done, like it is not actually cast iron, therefore I have not mentioned here. One is the, as I discussed yesterday, flux pellets. What is the advantage of flux pellets? So optimum property we have discussed 11 degrees centigrade, where there will be no free lines and there will be no slag generation, there will be no accumulation phenomena. That pellet we have tested in electrical furnace or in removal with the conventional line charging. So what is the difference? Okay. तुम्ही ऐसे क्या गोल्डन जुबली में आए, गोल्डन जुबली में आओ, डिपार्टमेंट का मेरा sustainable steel making means sustainability. It means it will reduce the emission level, reduce the energy consumption, and another point I discussed in first PPT. Sustainable not to reduce the energy, not to reduce only the emission, but also to reduce the waste generation. If your process generates a lot of waste, it is not a sustainable process. So here I will discuss how to decrease the waste generation. Mainly if you see the steel making means the waste generation is the slag. So it is like 1 ton of steel production. If you see the solid waste generation is like iron making slag, steel making slag, starch, gas, okay. Simultaneously gas waste, gaseous waste will be also generated. We are concentrating on now in this study solid waste generation. Okay. So it means majorly you see iron making slag, primary slag, secondary slag. Why is it required? Because here iron making will obviously generate. My concern will be the primary and secondary steel making slag. Because we are discussing regarding the sustainable steel making development. Okay.
Because the iron making is already being taken by the cement company.
I am not concentrating the slag utilization. Slag generation
is reduced.
This is my question. Slag generation. How to decrease the slag generation?
That is the best case scenario for blast furnace. Slag rate comes down.
But if you go for the DRI approach, there will be no slag.
Yeah, but
In iron making case, but you have to treat in steel making. Therefore, I am concentrating these these two. Okay.
You consider that it will be DRI. Yeah, you consider it will be DRI.
Then you have to handle the slag in steel making and refining both. So actually the slag is generated due to this removal of this impurities and conventional mechanism is all impurities it will remove through the slag bridge. CO except CO carbon except carbon you see silicon how many are? You can see all impurities removal in steel making is a double step process. This is the challenges. Double step means impurities removal. Double step process means removal of sulfur you have to treat another. Removal of silicon you have to treat another. Double step. Reducing atmosphere, oxidizing atmosphere, both atmospheres are required. Okay. It means always it is a double step process. Number 1, this is the challenge. Number 2 is blast furnace fuel fluid except carbon, all impurities are removed in the slag. Okay? It means minimum amount of slag generation, it is obvious you have to generate some amount of slag. Although you have
We
they
have
have
started.
the setup of
Metal recovery plant. It has been commissioned.
commission.
Asia's largest slag handling.
Then, in case of when we are talking about the sustainable steel making, and it should be obviously the removal of impurities, means reduction of CO2, reduction of energy, except that all removed impurities if it is removed in a one step, then obviously the time consumption will be less as well as the your energy consumption will also less. Number two is, suppose you ignore the slag generation. Now if slag is less or less odd mill, then there will be no problem issue of handling. Then what happens? If you see, the impurities are mainly the carbon, silicon, phosphorus, sulfur. Carbon can easily react with the, and it is already reacting. Therefore, it is removed through this oxygen, reacting with the oxygen. All impurities reacting with the oxygen, it goes to the slag. But problem is for the sulfur. And if you see, if you introduce any gas which will react with all impurities simultaneously, then that gas can reduce all the things, all the impurities. Sulfur, it is not possible to reduce by oxygen blowing. But if you introduce any such gas, it will react with all impurities present inside the liquid metal. Then what will happen? All impurities can be removed. Hydrogen can react with all impurities. You can see. It can react with carbon, manganese, phosphorus, sulfur, all impurities. Hydrogen can react. But the problem is the reaction of the hydrogen present with the sulfur which is present in the liquid system, liquid metals. If you see the reaction, the positive gives free energy, it restricts the sulfur cannot react with the hydrogen gas. So if I want to react with the sulfur which is present inside the liquid, it requires, you can see, ionized phase. When it will be in the ionized phase, you can see hydrogen plasma generates a very high temperature, it is very to remove the sulfur from the liquid. Then it is possible to reduce. Okay? And when it will be possible, very high temperature is required. I think you can see on the fact this much high temperature is required, which is not possible in normal steel. Normal steel making temperature is 1500, 1550. In case of stainless steel, it is 1600. You cannot go beyond that.
2200.
It is required more than that. Then it means you have to go generate. Number one is high energy, high temperature. Number two, your hydrogen should not be as a hydrogen gas, because thermodynamically it is not possible to react. Then you can go for the plasma. Then slight short regarding the plasma, because a lot of arts and things are there. They are already telling, next session is first universe. Okay. So plasma is actually a fourth state of matter. You know, it is hot ionized gas consisting of an approximately equal numbers of positively charged ions and negatively charged electrons. Two types of plasma are there. One is the non-transfer, another is the transfer. Non-transfer means, if you see, the electrons are directly emitted. It is actually negative and positives are there inside the torch, and the flame will be generated. Okay, only you will get the flame. Therefore, it is actually the non-transfer, means earth is not directly struck to the liquid metal. Here, if you see, liquid metal is acts as a positive, and at the bottom it is the liquid metal, it is conductive in nature. But when we will go for the asmelting I will emphasize this slightly. Asmelting, what is the problem? In our laboratory it is okay. We have added some 500 grams as after that we part after a certain fluctuation where the conductivity will be there, then it will melt. But think about the its bigger use like industrial scale. Then it will not be a batch process, it will be a continuous process. Okay? In industry it requires continuous process. It means continuously you will charge the as material and continuously you will take out the metal. It should be preferable for industry. Then what is going at that condition? What will happen? Always the slag layer conductivity it will disturb. Like initially when you add the as content, then slag will be the viscous in nature. When it will be melted, then some conductivity will be there. Then arc will pass. This is the one of the biggest problem of transport of lava. Okay. We have also some modifications in our system. Okay. Here we can use as a transport, non-transport when it is required. Which initially is and finally when the liquid metal will be melted, we can switch over to the transport so that heat generation will be high, the energy requirement will be less. Okay. Therefore, this is here we have for past experiment like impedance regular new value we have taken peak iron. Typically high means impurities containing peak iron. It is generally when a blast furnace under lining, when this after lining, if you collect the sample of the peak iron, it will having a high sulfur, high silicon, and there are some reasons like high sulfur is due to the lower part temperature and high silicon in this way because high coke consumption at that time. So typically you have collected some pig iron, minus 2 iron, it is almost impurity free and argon is the stabilizer gas. If you introduce some amount of argon, the stabilization will be more. So mainly from this study, we have got like up to 70 minutes exposure time. We have got 99% removal of the carbon, 81% alpha removal, 76% silicon, 41% magnesium, 31% phosphorus. Then that was you know why magnesium phosphorus. Less one in this answer.
Why this arc should get destabilized with increase in hydrogen?
It actually hydrogen is not a stabilized gas. Okay, in case of arc welding also you can see some seating gas and stabilizer gas, both gases are there. So argon, what will happen? It will make the arc stable, it's continuous arc. Otherwise what will happen? The arc will be, sometimes it will be continuous, sometimes it will be disconnected. Again you have to adjust the electrodes. In this way, if you only give the hydrogen, then it will not be a stabilized process. But if you provide some amount of stabilizer gas, arc will be stable. If arc is stable, then heat generation, heating will be high, and simultaneously your hot. So it means, and we have achieved the steel grade, normal carbon steel grade.
So this improved material was bigger.
Have big iron. Initially, one system was in big iron, and different system I have to do this one. Like when we prepare the ATS system, then we have taken only the pure big iron and APS to mix it to make the APS iron APS system. After that APMNS. From the APS system, we added the magnesium. In APS system, we added the phosphorus. In this way, we prepare the mix made first. After that, we part the hydrogen gas. And so then, why this magnesium phosphorus is less? If you see magnesium actually in our system, when for the kinetic study it requires sampling a regular interval. When you open the lid, there will be some air entrapment inside. Okay? Because at that time, arc will be, you have to stop the gas. At that condition, when you stop the gas and you remove the lid, there will be oxygen, means air entrapment. Air contains oxygen, it will produce the manganese oxide layer at the surface. Then this it creates the problem of the further removal of further magnesium. Okay. I think we have done the regression analysis in different parameters how it is affected. Because it is a area of my student. When we are done it.
Where was it carried out, sir? Where was it carried out? Experiment where it was carried out?
Oh, yeah, Ramesh.
Which one? Singapore?
Here, in our state. So, the neural network based prediction model we have also studied because normal prediction means regression, it will not give you the data because think when you are considering the multi-component system, what will happen? You are putting the hydrogen and gradually all parameters are decreasing simultaneously. I say like only carbon will decrease first. After that, sulfur will decrease. Simultaneously decrease. Therefore, normal regression analysis cannot give you the exact explanation. Therefore, we have prepared the neural network based prediction. Then we have published 2 papers on this. Second area we have the metal extraction from the industrial waste. At my PhD work, and on that day I skipped that one. Here we have taken different bottomless, okay, iron slime content. I will tell you why iron slime is required here also. Okay. And you can types. We have changed the crucible lining materials like graphite, andesite, and we have normal, which there will be normal arcing, nitrogen plasma, as well as the hydrogen plasma. And smelting time we have varied from 10 to 18 minutes. And production they are characterized them was done for the liquid metals like different elements and how much liquid metal is produced. Slag, how much slag is produced and their composition. Dust, how much dust is produced and their composition. This is the different composition mix. How we have done? Like initially we have made data because directly I have told you in case of transferred arc plasma, you cannot directly made as materials, which is non-conductive nature. Therefore, it requires some conductive medium initially. After that, what will happen? Continuous metal will produce. Continuously you will take out, but there will be some liquid metal. Always it will maintain the connectivity of the electron transfer. Therefore, initially metal is required. Some half of the scrap material we have made. After the remaining scrap material are melted. When total metal pool is prepared, then you can see the switch over from normal arc to plasma. Means the only just auto electron to introduce the gas so that the plasma will generate. Okay. Then after melting, gradually we are taking out the samples. Okay. This is the different materials like in case of different crucibles, I have discussed graphite crucible, magnesite crucible, different iodizing gas, different exposure time. Okay. If you see the exposure time, this is 10 minutes, 30 minutes, 60 minutes, 80 minutes. Okay. Silicon, aluminum, manganese, different metals are is removed. Okay. This is what charge material, pellets as well as powder. You have observed that if you charge the pellet material, there will be less recovery as compared to the powder materials. Because pellet materials, these are particle space are more at high temperature when the specific metals like aluminum, it evaporates. Aluminum having the lower vaporization temperature. Therefore, at that temperature, if the metal is produced, you have provided intense heat. What will happen? It will easily escape out. But if you put a buffer like fine starting, what will happen? It will effectively capture the produced reduced metal in that layer. Therefore, you will get the higher recovery. Crucible types, if you see the graphite crucible, actually it shows the higher reduction there because the arc stability. Because graphite electrodes is already conductive in nature throughout the area, electron can transfer, therefore arc stability is better. Therefore, it is the reduction of carbon content, okay, half stoichiometry, increasing stoichiometry, second stoichiometry, without stoichiometry, charge there. Ultimately, what we concluded from this study, the partial recovery of aluminum and silicon in the metal bar indicating the carbon cycle reaction of aluminum and silicon in the charge at all. It means as we use carbon content, therefore in nitrogen plasma, like the nitrogen plasma also you can get the metal. It means you can recover the metal, but it can be enhanced by using the hydrogen plasma. Then the carbon percentage in the charge mix or the pellets you can calculate decrease. Different papers from this study, and we have published one paper which I discussed like pig iron class pellets, optimum class pellets for the removal of impurities from the pig iron, and we have induction melting furnace, and we have compared with the lime, conventional lime also. Okay. Then another one we have done in this furnace is stainless steel production. Stainless steel production requires, if you see, one is the perfection, making it normal stainless steel, if you see, the chromium is required, and for making the steel, you can see it requires a very low amount of carbon percent. So conventionally, how it is prepared? Low carbon ferrochrome is required. This ferrochrome is alloy element which is used to get the chromium content in the steel. But low carbon ferrochrome is required, otherwise stainless steel grade will be the high carbon and it will not give you the stainless property. Then another is required chromium and nickel. Indian context, if you see, we don't have the nickel. Okay? So we are dependent on from the other countries to get the nickel. Then a lot of research, I think Promodar is familiar, nitrogen bearing stainless steel, which nitrogen will replace the nickel content. But how much? Near about normal atmosphere, you can easily 4,000 ppm you can introduce easily. It depends upon the chromium equivalent and nickel equivalent. Like chromium equivalent means if you increase the alloying element, then the acceptable means absorption capacity of the nitrogen will also vary. Okay. So depending upon that, you can introduce 4,000 ppm. Normal atmosphere, if you see 500 ppm hydrogen, it can be absorbed. Like in this monsoon season, if you prepare on steel, carbon steel, 500 ppm already it will absorb from the atmosphere. Okay. But if you vary that from alloy elements, it will vary. They are not 4,000 ppm, it can absorb. Then what does stainless steel making in India scenario? If you want to go for producing stainless steel, it requires only the nitrogen, which can replace the nickel. But your requirement with the chromium. Chromium is essential one. Then chromium, and in place of nickel, you can use nitrogen, and if you use nitrogen there, some magnesium. Okay. Then if you analyze the chromium overburden materials, chromium overburden materials contains Cr2O3, chromium oxide, and it contains the manganese. Here, sorry, some amount of nickel, and if you add the manganese ore, and if you smelt it, what will happen? You will get an alloy which contains chromium, manganese, and your requirement will be in place of nickel, it will be a hydrogen. Yes, sorry, hydrogen. Then suppose you made that materials in plasma furnace, because plasma furnace in this chromium Cr2O3 having higher melting temperature, it will not react easily with the carbonaceous materials. It means high temperature will provide by the plasma, and high temperature will accelerate the reduction of Cr2O3. Manganese oxide, it will reduce to make the manganese, and it will form the chromium, manganese, iron, alloy. Okay. As per your requirement, you have to adjust the composition. Then the question will come: to make the production fast. Then the question will come: what will happen? We have prepared here. We have prepared one like Cr2O3 overburden. Okay, it contains 52.3. Fe2O3 was 33. Okay, then to adjust the composition, mild steel is also there. Okay, then we have prepared different mix composition. If you see here, chromium recovery in case of hydrogen plus. Sorry, only hydrogen. It is only hydrogen plus charge contains the carbon. So if you see only hydrogen plasma, the reduction recovery is less. But with addition is stoichiometric carbon with the double and stoichiometric carbon. What is the main next slide you can see that recovery is like there you can see almost 60%. With time you can see it means in this time up to 20 minutes exposure then almost you can get the maximum cost. Yeah. Okay. Then the beauty is like here you can see when you use hydrogen carbon is less. Okay. But when you use here chromium, yes, you can see chromium content is actually here. Okay. Here means mix number 3 it with nitrogen. And our requirement is also the nitrogen. Therefore, if you change the composition of the plasma, what will happen? And when your requirement is the nitrogen absorption, you put the nitrogen absorption, nitrogen plasma. Then you withdraw the nitrogen plasma. Insert the hydrogen plasma. What will happen? Hydrogen will react with the carbon. It will react with the carbon, as I have discussed in the past case, and it will give you the grade of stainless steel. Actually, what happened in this paper and we have published at that time, we proposed this one. We have prepared the crude stainless steel grade, but at that time hydrogen plasma, by hydrogen plasma we can reduce. At that time we actually did not think about it. But when we introduce the hydrogen plasma in that cases, these students were, then we understand it, okay, if we introduce both plasma simultaneously, means initially nitrogen plasma, that will be great. After that, switching over from nitrogen to hydrogen, then we will get the, as per our requirement, we will get the stainless steel direct. Okay. So, just last slide. What are the challenges of smelting the steel? But I have discussed all of this. One is the material charging code. How to charge? Two types of charging effect. One is in-flight plasma. In-flight plasma means through the nozzle. Tube. You can directly charge. And because plasma means one arc pressure is there and also the gas pressure. Therefore, a lot of fines it will come out from the system and it will go to the ESP. Okay. Therefore, we have tested what is the effect of pellets. If we prepare the pellets, there will be less emission. Your emission. Conductivity of bath product I have discussed, and handling of the large slag. When we talk about the waste material treatment or recovery of metals from the waste materials, what will happen? Suppose valuables are 10%, 90% are the other oxides. Then it will generate a huge slag, and slag density is less. Therefore, volume wise it will generate